Hello, this is Brian Hall presenting my standalone solar photovoltaic project for the UMass Lowell course Intro to Alternative Energy. My project consists of two solar panels, a lead-acid battery, an inverter, and household devices that can be run from the battery after it is charged with the light energy from the sun. My first solar panel is a module of 20 cadmium and selenium cells. It's a CIS, and each one is rated at 5 volts DC and up to 100 milliamps. Each horizontal string going across, as you see, consists of 4 cells, and those 4 cells are in series with each other, providing a maximum of 20 volts per row. And there are 5 rows in parallel for a maximum of up to 500 milliamps. Okay. After several experiments with the CIS module, and possibly due to how I have the panel mounted in the window up vertically, and not for the flatter angle to be perpendicular with the sun's rays, I decided to get this second panel, which is rated for 7 watts max of power, and under full sun provides about 20 volts of output. So 7 watts divided by 20 volts is about 35 milliamps of current at most. But this Amorphous silicon panel, as a single unit, does provide me with more reliable voltage and a faster rate of charge than does the CIS module by itself. The battery receives its charge from the sun that goes down here through the solar panels, and I did start this project with intent to use a charge controller. The controller prevents the battery from overcharging or undercharging. However, the amp hour rating of the batteries used are low enough that during the night without the sun, the battery voltage drops significantly by about 2 volts each time. Say it's 11 volts now. If I let this sit in the dark overnight, I would see it at about 9 volts or so, as I found in the course of my experiment. And I even tried using a diode on the battery to try to prevent leakage, but that was not successful. I researched and learned that a deep cycle marine type battery, which tends to start at about 20 amp hours or even up to 100 amp hours, is best to use for these type of systems where a charge controller is involved. But my limited budget did not allow me to purchase such a battery. They ran around $100 or more, and I wanted to build this project using mostly what I already had around the house, which included both this 2.9 amp hour battery, which just was not successful at all in the charging process. It would lose charge too quickly, so I mostly stuck with just the 7 amp hour 12 volt battery, which I already had. The charge controller does offer some nice features, such as battery voltage power indicator, similar to what you have on the solar panel. An indicator to show you that the solar panel is indeed connected. It shows P for your photovoltaic. It's there we go. We have 11.9 to 12 volts coming in. Even though there's, with these panels in series, that with a multimeter, I measure closer to 25 volts off of these panels. Now, C is your current off your panels, which is 0.0. That means less than 100 milliamps. I have the panels in series, as I mentioned previously, because that does end up working best for charging, even despite the under 100 milliamp display. This is a charge mode. This is L. There's an option to connect a 12 volt load, such as a 12 volt lamp or what have you. I don't use that for this project, but it's there. And a kilowatt hour rating. The wattage off of my panels is so low, it's less than 1 kilowatt, even less than 0.1 kilowatt, so it displays 0. And back to battery voltage. And not only can the battery store the energy from the solar module, but the module itself produces enough electricity to light the small LED bulb. I don't know if you can see, but it is on and producing light. Right, the source of the model parts were the MIT flea market for the cadmium indium sulfur sols, the Amorphous silicon panel, this battery, this UPS power supply, which is an energizer. As you can probably tell, this battery is actually compatible with this power supply, so that happens to work to my advantage. I also went to Radio Shack to get this bulb, the crimp-on connectors, and a hardware store for the light bulb and base, and I got the charge controller from Amazon. So after the battery is charged up to at least 12.5 volts, the inverter can be used to convert the DC voltage to 120 volts AC. As you see, the inverter is not plugged in to the wall, using the part of the UPS where, as if the power were to go out. And so what's going to happen now is this battery, charged up by the power of the sun, is going to give the 12 volts DC, and the inverter electronics will convert that into an alternating current 120 volt signal. So let me go ahead and demonstrate that now for you. I just connect up the red wire, the red post of the terminal, and the black wire to the black post of the battery. Hit the button. And we have 120 volts of alternating current powering a 100 watt light bulb. As you see, it's running for several seconds, but on my earlier tests it ran for only 1 single second. This is a much better test result. Again, not plugged into the wall at all. This is 100% battery power, stored solar energy, now going through an inverter into an alternating current sinusoidal waveform. And as you see, this project works. I do, however, wish to demonstrate other devices that can be run. So let me turn this off. Ooh, that got warm pretty quick. So there is 100 watts. And now we'll go ahead and demonstrate just a little bitty 7.5 watt, you call a utility light lamp, so such as what might go in your refrigerator or something. As you see, this will easily be powered as well. We easily have 7.5 watts. It's probably go on for some time. But I have something a little bit more fun to demonstrate for. Okay, now, so here we have 14,000 volts at 35 milliamps, which is actually about 490 watts. The power supply, the inverter is rated for only 400 watts. So let's see what happens. 3, 2, 1. A nice sustained. And I turn the power off there because, yes, we can draw that 90 watts more than the rated current and get a nice big fat electric buzz going from there. That was so cool. let me show it to you again. And I turned it off manually. Wow. So those are examples of what we can do for powering 120 volt appliances. For example, let's really put it to the test and run our 100 watt bulb and our 490 watt supply at the same time. Can we do that? Yes. So, as we have now clearly demonstrated, there is plenty of usable power in that battery, which is stored energy from the sun. Right, getting back to it, I simply connect the battery to the wires, holding the power button a couple seconds, as you just saw, and I have usable 120 volt power for the appliances. So there are also many 12 volt systems. For example, most every car battery is 12 volts DC. And computers, if they're laptops or desktop powers that plug into the wall, also run internally on 12 volts DC. And with this fan, as you can see, it is currently not turning. But when I connect the appropriate wires to the... Let me see. The fan turns. You could probably just hear it too. And when I disconnect, there the blades have stopped moving. So here we have photonic light energy from the sun went into the solar panel, stored as chemical energy in the battery. This chemical energy is now converted back into electrical energy. We turn it into light and heat energy through the light bulbs, as well as light and heat and electrical energy in the high voltage transformer. And we're converting it here into mechanical energy by means of the fan. There it is again for you. Probably run that for... Found that this neon lamp is neutral in terms of polarity. But there we go. And here we are. I have like a little, well, it weighs probably about 2 or 3 pounds, but it's a flashlight that I could go around, or say have it be like a safety indicator at the end of the driveway if I'm stuck on the side of the road. And there you have it. There are my successful experiments. So, to conclude, I have created a renewable energy station that allows me to collect sun through photovoltaic means. This system operates independently from the grid. I can keep recharging the battery, or even get a bigger, better battery if I want to, and keep cycling it over and over, because I get as much sun as I need for free, provided that the weather cooperates. And this concludes my presentation. Thank you very much for your time, and have a great day.